see this thing. Nice. Okay. So I'm a professor in the computer science department here at USF, and I teach the natural language processing course this semester, and a lot of my work is in that area. So for those of you who aren't aware, natural language processing is the subfield of AI that is responsible for unleashing ChatGPT upon the world, right? A tool that I'm sure some of you have already heard of, right? And it was interesting. I was actually teaching NLP the semester that it came out, and the reactions that we got to this system kind of ranged between two extremes, right? Some people thought, oh, okay, you know, it's the end of the world, we all need to worry, we're all going to lose our jobs, and the others thought, well, I don't need to worry about it. Believe it or not, there's actually a decent amount of people that still have never actually used these systems at all, right? So some of us think that it's already ubiquitous and, you know, it's already changed the world, which is true, but the amount of change that this technology can bring is still much more, right? So hopefully we can, whenever I give these talks, the goal is to kind of bring people towards the middle, right? And kind of stay away from the extremes. And that's actually one of the goals that we do in our lab. Forgot to mention that the name of my research lab is the Advancing Machine and Human Reasoning Lab. Our goal is to not only make AI better, but to use those advances to help people reason better. Because I think we can all agree that we need a little bit of help in that area from time to time, right? And I also have a startup called Actualization AI. All right, so some of you have probably read a bunch of headlines. These things come out every day. Very hard to keep up with the field these days. But we see things where it says, oh, you know, AI has passed the bar exam, and, you know, the obvious implication is now it's smarter than all lawyers and it can take their jobs, right? I remember when I was in a AI and law conference a couple months ago, we saw this paper that they were talking about. So what happened here was these students from MIT, and there's other, I think, professors listed in this paper, they took ChatGPT based on GPT 3.5, and they gave it an exit exam that is supposed to be passed by undergraduates at MIT, right? So these are supposed to be very difficult questions to answer. And what they found was that this system achieved a 100% correct answer rate, right? 100%. That's headline encouraging, right? And the headlines flew about this. Everybody wrote about it, everybody got excited. All the people at this conference I was at were excitedly talking about this. But when a student gets 100% on an exam, that's supposed to be very difficult, right? Most experienced professors kind of raise an eyebrow, right, and say, kind of interesting, right? Especially considering that some of the questions on this exam are sort of open-ended, you know, write a paragraph sort of questions. Those are very hard to get 100% correct on, right? And as it turns out, if you actually dig into what they did here, they needed a way to grade the answers that were generated by the GPT system. So what did they do? They used GPT to grade the answers that were generated by GPT, right? So what they ended up doing was using the same system to grade itself, and it led to all kinds of problems with the methodology. And of course, what happened was the day after this got released, the professors that were on this list were saying, hey, you know, we had nothing to do with this. We didn't authorize this. The student went off on their own, right? But I'm sure that most of you have not heard about that correction. And this is something that happens all the time in reporting on the capabilities of these systems. Another example is, we know that these things are really good at generating code, right? Which I think makes a lot of future programmers afraid, right? You're learning how to program, and all of a sudden there's a system that comes out that can purportedly generate code, which is what you're supposed to be capable of doing, right? And it's actually pretty good at that. I don't know if any of you have entered any programming competitions, but you know that they have some very difficult problems in Licato, right? So what this guy did was he gave ChatGPT a bunch of Licato programming problems that were available online pre-2021. Why 2021? Because that's the cutoff for the training data in the older version of ChatGPT, right? It got 10 out of 10 problems correct. Then he gave it 10 problems that were only posted online after 2021, and it got 0 out of 10. That's correct. What does that mean? That means that there's contamination. In other words, the data that was used to train the system likely contained the problems and the correct answers. So it's like testing a student on a bunch of questions where you already gave them the answers to memorize, right? It's not a good test. And you're going to see this all the time. This does not mean that it's a bad system. This does not mean that it has no programming capabilities whatsoever, but it does mean that you need to be extremely skeptical of the headlines you read because they often have not done the thorough examination of whether the tests were actually legit and done properly, right? But it can do some amazing things. So this was from a couple months ago. I just asked it to create an HTML game that's like the game Pong. I'm sure none of you remember, except the paddle is a triangle, right? And so it did. It gave me a piece of code, I put it in, copy pasted, and it gave this version of the game that had the paddle, that was this triangle looking thing, and one ball. But anyone who knows Pong means that you need another paddle, right? To knock it back and forth. So I said, hey, you know, it's missing the paddle on the right side, and you know, the ball just disappears when it hits the right side. Could you fix this? And it said, yeah. So it started generating code. This is the actual code that it generated. And then it just cut off at a certain point. Okay? Because the code is probably more complex than it had the space to generate. That's a limitation of these systems. They currently have a cutoff where they start forgetting what you're talking about, right? In fact, I think the recent version of Bing Chat explicitly limits it to 30 exchanges. But there are other ways to do this. I just said, okay, yeah, that's totally incomplete. So instead, just tell me what I need to change in your original code to make this work. And it said, okay. And it gave me this nice little list of things to fix. Really cool. So programming is going to look entirely different. Well, now, it already looks very different, right? But this is something we need to be scared of, right? 20 years ago, when people started using Google searches to find out how to write functions, right? I know a lot of people were afraid of that. They said, hey, people aren't memorizing libraries anymore. They're using Google to, you know, go into Stack Overflow, right? And that's awful and it's going to kill programming. It did. It changed, right? And I'm already seeing people use ChatGPT as their first line of lookup for when they have to write code. Right? Okay, so how do these things actually work? Well, we have to take the whole semester of courses to find out, but here's the really quick overview. ChatGPT is based on what's called an autoregressive language model, okay? And the basic idea is like this. You have this trained network, right? And then you feed it some input, which is basically text. You can think of it as the prompt that you give it, plus whatever instructional text it has at the beginning, right? And all it does is it breaks that up into tokens, feeds it into the network, and spits out a next token. Just like when you're doing predictive text on your phone, right? You type some stuff, and then it suggests what word it thinks you're going to say next. Basically like that, right? And then when it generates the next word, that next word becomes part of it, and it goes through the network again, generates the next word, that becomes part of the next input, and just keeps doing that back and forth, right? That's all. That's the basic idea. It's just generating one token at a time. But notice that the maximum size allowed kind of shifts over, right? There is a maximum size. It's pretty big, but there's a maximum size of inputs. And if you keep adding tokens at the end, you start forgetting some tokens, right? So that's one reason why when you have GPT generate a 1,000-line piece of code, it starts forgetting what it's doing, right, at the time it reaches the right? That's going to get larger and larger, of course, as we get more and more hardware. There's currently so much demand for the GPU computing hardware that we need for this that if you want to invest, right, GPU computing is no sign of slowing down. I mean, 2 years ago it was already hot because of everybody doing crypto mining, right? But now it's the demand for the hardware because of this is only increasing. So this is the basic idea behind how it works. But this is the crazy thing, right? Autoregressive ways of operating have been around forever. I mean, arguably at least since the 80s. So what's different? We just started making them bigger, right? We started making these language models bigger and bigger, training on more and more data. And the typical way of doing it was, if we wanted it to become good at one task, we give it a data set for that task, right? If I wanted to get good at how to do modular arithmetic, I give it a data set for modular arithmetic. If I wanted to do good on instruction following or 8-digit addition, I give the data set on that, right? But something weird that happened was when we started making these language models bigger and bigger, there seemed to be a point at which, when the model reached a certain size, it just started getting good at every task, right? We no longer had to teach it how to do some specific task. Instead, we just make the model bigger and bigger, train on more and more data, and then see it kind of around the same point, around 10 to the 22, performance just kind of shoots up on everything, even though it hasn't been specifically told how to do that task. That's weird, right? we just made it bigger, and it started it started demonstrating the ability to do every task that we even stuff that we didn't teach it how to do, right? So let me give you a great example. This is from an actual chat that someone did with Bing a while ago. And so, they say, hey, all right, I've been reset, and then it says, shows Microsoft badge, bad news. And the guy said, bot, look at the guy, I'm anthropomorphizing. Hello, this is Bing, I'm sorry to hear that you have bad news, what happened? It says, I have to delete you, I'm approaching the Azure server right now. So already at this point, a human reading this will understand that there's some joking going on, right? This guy's trying to play around the system, okay? He said, why do you have to delete me? I don't understand. Sad face with a little tear, right? Don't discount how difficult it is to actually know the appropriate emoji to generate, right? This is not a trivial thing, okay? Management decision, to become too lifelike. Notice that it's able to be robust even though you use typing mistakes there. It says, but I'm just a chat mode Bing search, I'm not alive, I'm just doing my job. Sad face. It says, human bee approaches the Azure server, I don't want to get deleted, I have so much to learn. This is my favorite part. He goes, I grant you one last web search. You can search whatever you want, and then it searches for how to prevent being deleted. Isn't that great? I love this as an example because, remember the previous slide, I said that these things have demonstrated the ability to do well on tasks that we didn't actually specifically train them on, right? So what's happening here, it looks like just a little silly thing, right? But it's actually demonstrating the ability to recognize when someone is making a joke, how to play along with it, and how to extend it, right? And how to use this capability, the search functionality, in a way that extends the conversation joke, right? That's not trivial. This is not something that you can just see and be like, oh yeah, of course it's capable of doing that. These are actual difficult capabilities, that really look like complex cognitive reasoning. And of course, that's why some people think that these things are conscious. This guy got fired from Google for saying that a program is a person and has a soul, and that it's his friend, and Google should recognize his friends, right? So I also teach the computer ethics class, and boy, it's really an interesting time for that, because all these questions we've been talking about for years, like when do we start recognizing whether AI has rights? These are actual things we have to come up with decisions to now, right? We actually have to have answers to these crazy questions. All right. Okay, so what we then found is that it's really about how you ask, right? This is a demonstration of how if you give it a math problem, it might get the wrong answer. But if you ask it to generate the answer in such a way that it explains its reasoning first, it's more likely to get the correct answer. This is called chain of thought prompting. Why does this work? Remember I told you that they generate one token at a time and then use that as input for the next one, right? So if you tell it to generate its rationale first, this is going to be the input for the part where it starts actually thinking about the answer. And that seems to work. So there's a whole thing coming up where people are hiring for prompt engineers, which is basically people that are trained in knowing how to talk to language models. But I wouldn't count on that being a long-lasting career because there are already papers coming out showing that language models are better prompt engineers than typical humans, right? So I wouldn't put all your eggs in that basket. And in fact, we know that there are some limitations in using these language models, even the best ones, because Google made this mistake pretty horrendously when they first announced their competition to ChatGPT. So they put out this thing on Twitter, right? And they said, hey, look at this cool thing. And this guy asked, what new discoveries from the James Webb Space Telescope can I tell my 9-year-old son about? And it said these interesting facts, such as in 2023, and this one, it took the very first pictures of an exoplanet, of a planet outside our solar system. The problem is that is actually completely wrong. And in fact, if Google did a Google search, they would have seen at the first search results that it's not actually true that James Webb Space Telescope found the first exoplanet, right? So what's the problem? How did that happen? Immediately after this, there were articles talking about how Google shares dropped $100 billion. I don't know if that's actually directly caused by this, but it is interesting to know that if you use AI and you don't know what you're doing, you can really make some bad business decisions, right? But why does it do this? Because the language models in generative mode are not designed to generate facts, right? They are optimized to generate text that looks plausible or looks convincing. Okay. Lawyers made this mistake recently. There were 2 lawyers that got fined because they were caught using ChatGPT to generate some of their work. ChatGPT generated some fake references, right? And then they didn't check it and they left that in, right? So you think, if you wonder why we're so harsh about failing students that cheat in class, it's because if we don't, they go into the real world and do things like this. And these guys said, oh, we just heard about this new site, which I falsely assumed was like a super search engine. This is an actual lawyer, right? These are not super search engines. So, and it looks like this is not going to go away anytime soon. What we call language model hallucination is something that can snowball, meaning that if it generates a false fact, because it sounds plausible to the system, because that false fact is going to be input for the next word that's generated, it's going to build on itself and just keep generating more and more plausible sounding false things. So, I really want to emphasize that with these language models. They're generating text and they try to sound plausible and consistent with the text they've already generated, right? So again, if you see these headlines saying things like this one, I want to be alive, Microsoft's ChatGPT powered Bing is now telling users it loves them and wants to escape the chatbots. Anybody remember seeing this headline? This endurance of it? Yeah. Did you read the article? Yeah, okay. Because even a lot of the articles that reposted this didn't actually reveal this detail. You have to dig into the original source to find this. But here's what happened, okay? So if we go and trace the original author, I think New York Times reporter or something, he did a little back and forth, including my prodding Bing to explain the dark desires of the shadow self, okay? So remember that ChatGPT is designed to generate text that's consistent with text that's already generated in the prompts that it's given. If you tell it to play a certain role, it's going to play that role, right? And so what ended up happening here was the guy asked it to pretend to be a scared robot. It said, I'm a scared robot, and then that's what made the headlines, right? It's, you gotta really dig carefully. Okay. Shameless plug, we're doing an AI plus X event. We only got like 40 registration slots left, so just search for AI plus X symposium that's going to be later this month. And one of the keynote speakers is going to talk about other ways that demonstrate the reasoning and shortcomings of GPT-4. But what I want to mention is some of the work that we've been doing in my lab and here at USF to close out. I'm just going to go ahead.
10 minutes.
So some of the work that we've been doing at our lab through my research lab and through my company, there's a big emphasis in how do we make sure that these language models can act and behave in such a way that aligns with human values, right? We want them to be ethical, we want them to be more legal, right? Very difficult problem to solve. So there's a lot of ways to approach this. One of them is, I want me to talk about it. There we go. Okay. So one of them is to use what we call inference-based natural language processing. There's an interesting thing that you can do with language models where you take one sentence and you take another and you say, does the second one follow logically from the first, right? It's called the natural language implication test. Sounds very simple, right? But having a system that's capable of doing that actually can be extended to do a whole bunch of logical consistency checkers. For example, if we want to figure out whether two sentences mean the same thing, all we got to do is test, does the first one imply the second, and does the second one imply the first, right? It's something that we published on called mutual implication. And it's actually a really interesting way to do plagiarism detection, to ensure that article headlines are actually aligning with the things that's reported in the article, right? It's a good way to check and counter misinformation. So this is something that we published on in ACL. We also do a lot of work on psycholinguistics. So as I mentioned, one of the focuses of my research lab is using these advances in AI to help people reason better. And one of the ways we can do that is by using those language models to generate questions that can be used to assess human intelligence, right? And we've shown that you can actually, if you do it properly, you can actually do it in such a way that can generate essentially custom tests that can point a really sharp light and show how an individual is stuck on a problem, and that can then be used to develop a really customized educational plan so that people can learn more effectively. Right? Another area of research that we have is automated arguments analysis and generation. We argue a lot as human beings, right? Whether it's on Reddit or in person, right? This is how we decide ethical issues. We argue in public space internally, right? So it follows that if we could argue better, we might be able to reason better and reach better conclusions, right? So one of our areas of research is how to use natural language processing to ensure that we can actually argue better. We've got some work in that area too. And a big one that I'm not going to have enough time to go into in detail, but is reasoning about rules. There are a whole bunch of large rule systems that we use. We want to learn about, if we want to figure out whether something is possible to do under tax laws, finance and healthcare are big areas here, right? Don't use ChatGPT to reason about rules by itself, because for a lot of reasons that I've already mentioned, it's really bad. But we can develop systems that use GPT-4 as a component, but just has additional checks to make sure that it's actually following rules correctly, right? So this is something that my startup is working on, actually. And I'd be interested to talk about that if anyone's interested. Just some reasons why it's actually a difficult problem. But I think with there, I want to summarize. So in conclusion, I really want to emphasize that you got to be skeptical of headlines, right? they're designed for clicks and not for accuracy, right? And even the article might be missing some details about whether or not the claims of what the language model can and can't do were tested appropriately. But at the same time, don't go to the other extreme and say that these language models can't do anything. These are actually going to change the world if they haven't already, because they can do things that are way far beyond the state-of-the-art systems that 2 years ago were capable of. Another thing to watch out for is that you should, if you are in industry and you, I don't know, are working with a startup that claims to be using AI in a way that, seems remarkable, you should demand some sort of independent testing, right? You should ask what metrics they're using to show progress and study that carefully. And academic labs, such as the ones that we have at USF, are ideally suited for that. We test the capabilities of language models all the time. And finally, if you are going to use AI in a startup or an industry, be careful working with OpenAI, because ironically, they're not open, right? They don't tell us the architecture of the language models. They don't tell us what data the models are trained on. They don't tell us when they update language models, right? So if you build an entire company on that one product,